All right, we are back for the daily Leetcode challenge. Reordered power of two. Yesterday we had a power of two question. Now we have a similar power of two question. Let's see what we got here. You're given an integer n. We reorder the digits in any order, such that the leading digit is not zero. Return true if you only do this such that the resulting number is a power of two. What? You're given an integer. We reorder the digits in any order, including the original order, such that the leading digit is not zero. Return true if and only we can do this so that the resulting number. So you're essentially saying you can reorder the number to make a power of two. So like, for example, let me just do a test case here. Like 61 is going to be true because you can reorder it to 16. Is that what it's saying? Yeah. Hmm. N could be 10 to the 9th. Interesting. Uh. So I'm thinking we kind of like store all the values that are 10 to the 9th and do like a pentagram test essentially. So like build squares, right? And then like for each square, like get its frequency, get its freak value in some dictionary, and compare it to n. N's diff, essentially. And then if it's true, it's true. So I think that's the way we're doing n. Since n is like kind of parabolic, or it's parabolic, like the number 10 to the 9 shouldn't really matter in constraints because we're not going through it. We're just jumping. What's log? It'll be log n operations. So we have plenty of time. Yeah, this is a log n solution here because you're only dealing with each specific square. So let's create the dictionary for n. We do this in one line. It's let's convert it to a string first to get the specific a string, and then we have to convert it to a counter. I forgot for a second. Collections dot counter. And that gives us a dictionary of its frequencies and values. And then we'll go through each value. I don't know. I don't know where the bounds will be on this thing. Oh, okay. Let's just see for I in range. Actually, we'll do that. I don't. So essentially, what we're saying here is that while the ants is less than 10 to the 9th, because n can never be greater than 10 to the 9th, and ants is going to equal like the current square value, I think. So square is 0. And essentially what we'll do here is that we get the square of the ants, and then we square 2 actually, and then that's ants. And then we just essentially do this, and then so yeah, we're looping through, or while looping through, while we wait till ants is less than or equal to 10 to the 9. And we square root using 2 to the square root. We also have to, let's take this one here. And each dictionary, we create the dictionary for the specific answer. And then if the dictionaries equal each other, the original dictionary and the current dictionary, return true. Else we add 1 to ants. I like it. Or sorry, not ants. We would add 1 to square. Ah, forgot an equal sign. Looks good on that. We're gonna YOLO submit. Nice. Pretty fast. Pretty nice. What did we finish? 7 minutes. Not bad. Pretty simple problem. Not too difficult. You could do this in a for loop if you figured out how many squares are in a specific in 10 to the 9th, which you could do by logging 10 to the 9th, and taking the floor of it. So it would look like 4i in range, or yeah, it would look like 4i in range log 10 to the 9th, like math lore, I think it is, in the math.log. Something like that is what I would do, I think. I spelled math wrong. But something like that you would want to do. See if it still works. Nope. Because we forgot to do base 2. Nope, it's still too small. So there's a little bit of complexity there. Not exactly sure. They were failing the small base cases, but essentially, do you want to take the seal of it? I don't even know. I'm trying to think. Yeah, you do want to take the ceiling. Yeah, that makes sense actually, because some values would be inside of it. Yeah, so it's just something to work through. But yeah, that's how you would do it there. Probably is better to do it that way to be more precise. Like the bound, so that would do that. Yeah, I think that's a good solution, and I appreciate everyone watching.